All right, so let's try to put a whole bunch of stuff together, and in doing so, we're going to be able to find some trig values at some of our sort of like common slash like decent angles, but not just in the first quadrant, all the way around the circle, all sorts of different angles. So we need angles that line up with values that go with the special triangles that we did in the previous section. So let's just sort of remember for a minute the special triangles and what those setups looked like. 45, 45, 90, right, was sort of a 1, and then a root 2 was on the long side. We did 30, 60, 90, which had sort of 1 across from the 30, root 3 across from the 60, and then 2 along the hypotenuse. So we're going to need these values. We can kind of use those to find trig values at 30 degrees, 45 degrees, or 60 degrees, right? So for example, right, if I wanted to find the cosine of 30 degrees, I know cosines should be the adjacent over the hypotenuse, and if I look at my 30, 60, 90 from the 30 degree perspective, the adjacent side would be root 3, the hypotenuse would be 2, and I can get my value. Now those special triangles, right, are really only quadrant 1 angles. They're really only sort of referenced to quadrant 1. So what we're going to do is sort of leverage that. We'll use, right, the sort of signs in each of these quadrants, right, this sort of a smart trig class, a special trig class, to figure out the sign, positive or negative, right, aspect of the value, where each of these trig functions should be positive or negative. And we're going to sort of use all that combined with our reference angles, right? So the reference angles will sort of refer back to one of these angles that we've sort of been working with already. We'll have sort of a reference back to a 30, a 45, or a 60. So we're going to try to take all this sort of jumble of stuff and put it together to find some trig values. Let's just sort of like run some examples to get ourselves started. So let's do cosine again, but let's do something like cosine of 120 degrees. So before we do anything, right, we need to know where the heck is 120. 120, right, is between 90 and 180, so that's quadrant 2. So what I need here is the reference angle. If I do a little bit of a sketch, right, so whereas 90 is straight up, 120 is going to be something kind of like this. So my 120 is out here. If I start to draw a triangle in, I'll get something like this. This is not necessarily to scale. What we're going to see here is our reference angle, right, is going to be 180 degrees minus this 120. So our reference angle here is going to be 60 degrees. So that would put 60 down in this corner. And so what that means is, so in quadrant 2, I've got a 30, 60, 90 triangle. I have this triangle picture, and so I can use these same side lengths, 1 and 2 and root 3, but I'm in the second quadrant, so that means I need to sort of obey the rules of what's going to be positive, what's going to be negative in that quadrant. Let me sort of just pull this triangle picture out, right? So in quadrant 2, I'll try to draw this a little better also. So we've got 60 here, right? Kind of by definition, this is our 30. So this should be kind of 1, root 3, and 2. But because we're in the second quadrant, that means the x value, which we can see here, this should be negative 1, right? So this should be negative. Root 3 is positive. And then the radius, right, that 2 is also positive. So 120 gives us this particular triangle, right, this particular 30, 60, 90 with negative 1 on the bottom, root 3 and 2 both positive here. So what we're going to do then is to go back to the original. So our cosine for 120 degrees should be the, from this perspective, the adjacent, which is negative 1 over 2, would be negative 1/2. So the reference angle here was 60, gets us this sort of triangle on the position, gets us the side lengths. From there we got to figure out, so in that quadrant, which is positive, which is negative, and we can go from there. A little bit of work, right? But it's definitely doable. We're just sort of putting, again, kind of almost everything that we did so far together in this one problem. It's a real kind of culmination of all the work we've been doing so far. Let's do a couple more. Let's do a radians one. So how about tangent of, I don't know, 11 pi over 6, something like that. Couple things to do here. We got to figure out the quadrant. We got to figure out how big 11 pi over 6 is. We got a little bit of work to do here. So I'll sort of jump right to it. 11 pi over 6. So this is obviously bigger than 1 pi, but it's less than 2 pi. It's also less than sort of 1.5 pi. It's definitely almost 2 pi. So my position here should be quadrant 4. What that means then for my sort of reference angle, theta prime. So that should be 360, which for us would be 2 pi minus 11 pi over 6. That's going to be 1 pi over 6. This would be, right, times 6 over 6. This would be 12 over 6. So this is going to be pi over 6 as a reference. That would be in degrees, right? 30 degrees. So if I get a little bit of a sketch going, so our reference is 30 degrees. So in quadrant 4, right? My main angle is outside here, right? There's my theta. So this is my 30 degrees. This is my pi over 6. That means I'm working with my 30, 60, 90 again. What's my orientation here? So now my y value, right, is the side that's across from the 30. So that's going to be 1. This is in quadrant 4, so that's going to be negative. The x value is going to be the root 3, is going to be my adjacent. That's positive, and then my hypotenuse is 2, which is always positive. So my tangent pi over 6 is going to be based on this picture, so it's the opposite over the hypotenuse. I'm sorry, 11 pi over 6. So this is going to look like negative 1 over 2. Kind of a coincidence we're getting the same value we did up here. One of the things you see, right, if we're working from the same 30, 60, 90 triangle, we're bound to get a lot of the same types of answers. But of course, we're getting them different quadrants, different functions, very different ways. Oh, what did I just say? Tangent. Tangent is not opposite over hypotenuse. I spoke too soon, right? Tangent is supposed to be the opposite over the adjacent. So this shouldn't be negative 1 over 2. That's my fault. This is the opposite over the adjacent. Negative 1 over root 3. If we rationalize it, right, root 3 and root 3, the final version here is going to be negative root 3 over 3. Like so. Boy, that got a little sloppy. There we go. That's a 3. Yeah, that's as good as that's going to get. Let's do one more. In a pinch, let's do a bigger one. Let's do a degrees, but we're sort of bigger than 360. How about, I'll change up the function too. Let's do secant of how much? Let's do secant of 405 degrees. All right. So this guy's right bigger than 360, so let's do a coterminal first. So we're going to get an angle with the same positioning. So we'll do 405. If we subtract a rotation off of it, that's going to leave us with 45 degrees. That's quadrant 1, right? So that means our reference angle is just going to be that angle. The reference angle here is just going to be 45 in the first quadrant. If I do a little sketch, so 45, right, comes straight out. So 45 is here. Quadrant 1, so everything here is positive. 405, of course, technically is going all the way around and then some, right? So this is going to be 1 and 1 and root 2. If we sort of refer back to our special triangle, right, 45 is 1 and 1 and root 2. So we just going to have this flipped around the other way, but all the side lengths are the same. Quadrant 1, so everything here is positive. And then which function are we working with? Secant. So secant 405. So that should be the reciprocal for cosine at the same value. So that would have been, right, the adjacent over the hypotenuse, 1 over root 2. But if we flip it, we're going to have instead, the nicer, actually root 2 over 1, which would just be root 2. Right? So positive, negative, we're sort of getting from the quadrant, right? We're sort of orienting our triangles and sort of labeling them accordingly as far as the x's and the y's, being positive or negative, all that stuff syncs up with the quadrant. The lengths themselves, right, the triangles we're drawing and the side lengths that we're using are based on our special triangles from before. So you're going to want to have those handy as you're working through these problems. And then we're using a mixture of right reference angles, sometimes coterminal angles. We're just sort of throwing the whole kitchen sink at these guys. You know, we're using little bits of everything we did so far, sort of all throughout Chapter 5 to build this up. And that way it's very satisfying to sort of use all these things. Sort of a positive spin on it versus the negative spin, which would be like, oh my gosh, this is so much work. I can't believe I have to keep track of all this information. Think of these problems as a just a great opportunity to sort of really like make all the connections, just like form all the bonds between all these different ideas. Yeah, so that's the end of 5.3. We're going to sort of continue with this same kind of quadrant stuff in 5.4, but we're going to build a unit circle, which is going to be sort of leveraging the special triangles attached to a circle, all the quadrant stuff where the sort of radius is fixed at 1 in any event. That's for the next video.